6.7, polygons in the coordinate plane. Ooh, the coordinate plane is back. Our objective in this lesson is to classify polygons that are in the coordinate plane. So, how do we classify polygons? We know stuff about their sides, angles, and diagonals. And how do we do stuff in the coordinate plane? That should say 3 major formulas. So let's look at our formulas here. You know we have the distance formula. Distance formula determines length. This tells us when sides are congruent or diagonals are congruent. And next we have the midpoint formula. This is used to determine the coordinates of the midpoint of a side or to determine whether diagonals bisect each other. Right? Bisect means midpoint. We have 2 congruent parts. A bisector goes through the midpoint. And third is our slope formula. And what does slope do for us? Slope tells us parallel and perpendicular. So this will be if opposite sides are parallel, if diagonals are perpendicular, or if sides are perpendicular. And remember that if they have the same slope, they are parallel. And if they have the opposite, we'll write it out, reciprocal slope, that's perpendicular, right? Opposite reciprocal, change the sign and flip it. All right, so these 3 things, that's all we need when we are doing coordinate geometry. So there's your formulas. Let's go look and see how this works. If we want to classify a triangle, we are asked, is triangle ABC scalene, isosceles, or equilateral? And what do we use to define these terms? What does scalene mean? That's right, no congruent sides. What does isosceles mean? We know that one, 2 congruent sides. And equilateral, 3 congruent sides. All right, so the first thing that we need to do is we would go through and we would identify all of our vertices and label them as points. Doing this will make your life so much easier. And then remember, label them x1, y1, x2, y2. And so on this one, we are simply going to use the distance formula because we are looking at the lengths of the sides to determine if they are congruent. And we find that just simply substitute in using points A and B, points B and C, and points C and A. And we find that side AB measures 5 units, side BC measures 5 units, and side CA measures the square root of 50, which if you know how to simplify your radicals, you can get 5 root 2. This would also be about, we should put about 7.1 units. So that one's not the same, but what kind of triangle do we have? We have an isosceles triangle. 2 of our sides are congruent. AB and BC are congruent. Now, another thing we could do on this that they did not show here is we could determine, is it a right triangle? And how would we do that? Well, we would use our slope. And so we would choose like the slope of side AB, and you can either use the slope formula or on a nice graph like this, you can just count it. We know that slope is rise over run. So 1, 2, 3, 1, 2, 3, 4. So the slope of AB is 3 over 4. The slope of BC, and remember, you always rise first, run second. So 1, 2, 3, 4. 1, 2, 3. That's actually a -4 because we went down. Don't forget that. -4 over 3. Oh, that's looking good right there. And we should find the slope of the AC just to be thorough. So we would draw this triangle here. We go down 1. Remember, always left to right. And you always rise first, either up or down, and run second. 1, 2, 3, 4, 5, 6, 7 is -1 over 7. So from this, we can say that AB, segment AB, is perpendicular to segment BC, because right here, these are opposite reciprocal. So that means that they are perpendicular. So we could mark this as a right angle right there. So another good thing to do. All right, what's next? Well, I'm not going to make you stop and do this problem, but we will talk about how would you do this problem. We're given a triangle. We want to know what type of triangle it is. So we would use the distance formula. You don't even have to graph it. I mean, if you want to draw like a diagram and, show your points to help you kind of see what you're doing. 4 and F is 5, 2. Notice this is not even to scale where it would be on the coordinate plane, but then I would use the distance formula, and I would find the length of, use the distance formula, find the length of DE, the length of EF, and the length of FD, and then I would compare them, and we could determine what kind of triangle we have. All right, well, that makes this lesson a little bit shorter when we don't have to do those. Let's see what else we can use this for. Classifying a parallelogram. We are told that we have parallelogram ABCD, and we want to know if it is a rhombus. So it's already a parallelogram, so we don't have to check the slope to see if our sides are parallel. But how do we know if something is a rhombus? Well, in a rhombus, we know that we have 4 congruent sides, and we also know that diagonals are perpendicular. So we could do either of these. Personally, I think that checking if your diagonals are perpendicular is a lot easier than doing 4 distance formulas, because if we wanted congruent sides, that's distance formula, and diagonals are perpendicular, that's slope formula. And I see slope is a pretty easy formula to use. Okay, so we find the slope. So we're looking at our diagonals. We find the slope of AC is 5 over 6. We find the slope of BD is a -3 over 2. Are those opposite reciprocals? No, they are not perpendicular. So it's not a rhombus. Boy, they sure kind of look perpendicular on the diagram, don't they? We can assume nothing. And once again, I'm not going to make you do these. There will be enough of these on the homework for you to have fun with them, but we will look at problem number 2 here. It says parallelogram MNPQ has the given vertices. Is it a rectangle? Well, how would we know if something is a rectangle? We already know it's a parallelogram. Rectangles have 4 right angles. So what would we use for that? We would use the slope to find that. What else do we know about rectangles? We know that rectangles, the diagonals are congruent. So what would we use for that? That's distance formula. Okay, so we could use either of those. And how would we find out if it's a square? Well, a square is all of these plus we need either 4 congruent sides and those other 2 things, which is the distance formula. And we also know that our diagonals are perpendicular. So that's slope. So making things a square is going to take a few extra steps. But again, we are just checking sides and angles and diagonals. We are checking, are things parallel? Are things perpendicular? Do they make right angles? Are the sides congruent? So that's all we can do with these. All right, here, problem 3, classifying a quadrilateral. So we are told we have a kite. What is the most precise classification of the quadrilateral formed by connecting the midpoints of the sides of the kite? We want to connect the midpoints. So the first thing we're going to do is use the midpoint formula to find the vertices of the inner quadrilateral. And so we find our vertices, so then we mark them. Over 2, up 2, there's that one. Actually, that's negative 2, 2. Okay, over 4, up 2. There's that one. Over 4, down 2. And over 2, down 2. So yeah, that looks. So we are interested in this quadrilateral right here. Now, if you remember, the distance formula for horizontal and vertical lines is the ruler postulate. So horizontal and vertical lines, distance equals the absolute value of the difference of your points. So that's what's being used here. And another thing that we also know, this is from chapter 2, is vertical lines are always parallel. Horizontal lines are always, put an S there, parallel. And vertical and horizontal lines are always perpendicular. Go back to chapter 2 and find those things. All right, so we have done our distance formulas. We see here that opposite sides are congruent, so we know we have a parallelogram. And horizontal and vertical lines make right angles, which is going to give us a rectangle. And so I don't think we need to do this last problem. We can plot our points if we like. Isosceles trapezoid has vertices a 0, 0, 2, 4, 6, 4, and 8, 0. Connect our points. And so A, B, C, D. And we are told it is an isosceles trapezoid. We can see that these lines are parallel. We're told that it's isosceles, so we know our legs are congruent. And then we are asked what special quadrilateral is formed by the midpoints. So number 1, we would use the midpoint formula to find the midpoints. And then we would use the distance formula to show congruent sides or diagonals. We would use slope formula to show parallel or perpendicular, and then we could classify our figure that's in the middle. And so that's how these are done. It's a ton of fun. They do take a little bit of work. They are not difficult. Make sure that you label your points and then use x1, y1, x2, y2, right? Label your points and write your formula, substitute in, and they may be tedious, but they are not difficult. So there's a few of these to do on your homework, and as always, have fun.